In this video we'll talk about incenters of triangles. So let's talk about angle bisectors before we move on to the incenter. So an angle bisector would be, if I have an angle, let's call it ABC. An angle bisector would cut the angle perfectly in half, meaning that angle ABD would be congruent to angle DBC. Now, it turns out, if I have a triangle, and let's call it XYZ, I can create the three angle bisectors for my three vertices, and it turns out they will line up at a point as well. And this point is called the incenter. And again, not a fan of the term center in this case, but it's a way of finding a point based on these angle bisectors. And again, it's special in that it's pretty rare that three lines line up to make or to intersect at one point. So the incenter has some special properties. It's useful for a few things, and it's kind of a neat point to talk about within triangles. So let's talk about the theorem that goes along with an incenter. So real quick, let's get up a visual aid here. Let's make our triangle, let's call it XYZ, and let's make our angle bisectors. So I'm going to cut angle X in half, I'm going to cut angle Z in half, and I'm going to cut angle Y in half. And I know it's going to line up at a point, and let's call it P, and then I'm just going to label these points where it crosses the sides. Let's call them A, B, and C. Or I guess we don't need those points yet. So the incenter theorem states that the incenter is equidistant from the sides of the triangle. So remember that we measure distance along the perpendicular between a point and a line. So I know this kind of looks perpendicular, but let's draw one to kind of draw emphasis here. And this is the point we'll label. So let's call this one A, I'll call this one B, and I'll call this one C. And let's say they're perpendicular. I know they don't necessarily look it, but remember this is the distance. So this point P, the incenter, is equidistant from the three sides, meaning that if P is the incenter, then BP is congruent to CP, which is congruent to AP in this case. Now this is slightly different than the circumcenter theorem because I'm not doing distance to the vertex. I'm doing distance from a side. And there's a slight difference there. But again, another powerful result in mathematics. It makes the incenter kind of special in a lot of ways. And this is a theorem that we can use, and it can be useful to find some measurements that we may or may not have previously known.